Good afternoon, students. Okay, fine. Today I am planning to give you a short video on Newton-Leibniz formula. Now, what is that? Newton. What is that? Actually, this formula is used in definite integration to differentiate a definite integration without actually solving the integration. The formula is something like this. Let A is x1 to x2, these are functions of x, ft dt, then dA by dx would be direct formula you apply f of x2 into d by dx of x2 minus f of x1 into d by dx of x1. So what formula it is? It is actually to differentiate without actually integrating. I can prove this formula also. Now suppose we have say 0 to, for example, x t dt, right? And I have to differentiate it. So with the help of this particular formula, what I told you is replace this x2 by t. So x would be here into differentiation of x is 1 minus 0. So answer would be x only. Now if I solve it by traditionally like first integrating and then applying the limit and then differentiating. So it would be integral of t will be t square by 2. Limits applied from 0 to x. So answer would be x square by 2. So dA by dx will be 2x by 2, that is x. So you can see that here I need not do that integration part. I have differentiated it directly using this formula. It was a very simple question, but if we have a big integration is not that easy also. So first we need to integrate it by proper method and then we need to differentiate it. So it is a task. So always try to use this formula. Now this formula is used when you have to differentiate with respect to the function in the limits, not t. This is important. Then you can use this formula. Now I will explain. This formula is very clear. Now I will use this formula in one or two questions of limits. Now let me solve this question. Limit x tends to 0. X minus 0 to x cos of say t square dt upon x cube minus 6x. Suppose we are having this question and now I will solve it. Now if you have studied limits and you have an integration here, so either you first integrate this. Now cos of t square, integral of cos of t square is again that not easy. So then definitely you will use this thing. So now how do we use it? If I put x equals to 0, you can see that here it becomes 0. 0 to 0, the answer of an integration from 0 to 0 would be 0 only. So it is 0 and denominator also 0. So we got that 0 by 0 indeterminate form. So now we can use that L'Hopital rule, and in L'Hopital rule what we have to do, we have to differentiate the numerator and denominator separately. So differentiation of this would be 1. Now how do we differentiate it? Apply that Newton-Leibniz formula, replace t by x, so it becomes cos x square into differentiation of x is 1 minus replace t by 0, cos 0 is 1 into differentiation of 0, that is 0 upon x cube differentiation is 3x square minus 6. In L'Hopital's rule, never apply that quotient rule. It is simply differentiation of the numerator differently and differentiation of the denominator separately. Now you see this. This is fine. Now what we have done is, we have simply applied the Newton-Leibniz formula here. Now if I apply the limits here, to cos 0 would be 1. So it would be 1 minus 1, that is 0 upon 3 into 0 is 0 minus 6. So it would be exactly 0. So answer to this question would be 0 only. So this is an explanation of that Newton-Leibniz formula with the help of L'Hopital rule. One very important question now I am giving you. Now see, suppose we have a question like this. Limit x tends to 0. 1 upon x to the power 5. 0 to x e to the power minus t square dt minus 1 upon x to the power 4 plus 1 upon 3x square. Now this is again a question of limits. If you see this question, the first step, it seems to be a difficult question, because so first idea of this question is you should convert it into some denominator and some numerator form. So what is the LCM here? LCM would be 3 x to the power 5. So it will become 3 0 to x e to the power minus t square dt minus this would become 3x and this would become x cube. This would become this is 3x squared, so we will be left with x cube. Now it is fine. Now if I apply limit x tends to 0, this becomes 0, this becomes 0, this becomes 0, this becomes 0. So it is simply 0 by 0 form. Although I can use the formula, but right now I am explaining with the help of L'Hopital's rule only. So you can differentiate numerator and denominator separately. So this will be 3. Apply that Newton-Leibniz formula, replace t by x to e to the power minus x square into differentiation of x would be 1. Then differentiation of 0 would be 0. This is the only result. Minus 3 plus 3x square upon 15x to the power 4. This is fine. I am again saying I can use formula also. Limit x tends to 0, e to the power x minus x upon minus 1 upon x is 1. But I am not using that. Again I am applying extending to 0, e to the power 0 is 1. It becomes 3, 3 cancel, then 0, then 0. So again it is 0 by 0 form. So I can differentiate it again. So it becomes limit x tends to 0. 3 into e to the power minus x square into minus 2x plus 6x upon 60x cube. This is how it is, right? Now you can take something common if possible. So it will become limit x tends to 0. So you can take 6x or minus 6x you can take common. If we take minus 6x common, it will become e to the power minus x square minus 1, right? Minus 6x I have taken common upon 60x cube. So 60x cube can be written as 6x into 10x square. Idea is 60x into 10x square. Why I written like this, I will explain you here. See, this becomes limit x tends to 0. This is minus 6x upon 60x into e to the power minus x square minus 1 upon x square. You remember this formula, limit x tends to 0, e to the power x minus 1 upon x is 1. You can again prove it with the help of L'Hopital's rule. E to the power 0 is 1, 1 minus 1 is 0, 0 by 0 form, differentiate numerator and denominator, you will get e to the power x tending to 0, e to the power 0 is 1. So you apply the same formula here. Whatever value is here should be here. Minus x square is here, so you should have minus x square here. So here one more minus, so it would become plus. So now here you can apply this particular formula and this directly becomes 1. Now when it becomes 1 and this x and x get cancelled, so 6 by 10 would become 1 by 10. So answer to this question is 1 by 10. So we have, what I have explained you is how to use this Newton-Leibniz formula and directly with the help of L'Hopital's rule we have solved this question. But one thing I have always told you that it is always better to use formulas first, and if not with the help of the formula you are able to solve the question, then move on to L'Hopital rule. It's not vice versa. You should start with L'Hopital rule, and if it is not solved by that, then you move on to formula. Formula is always better as compared with L'Hopital's rule. I have explained you in many questions. Thank you.